Let's talk about Chapter 11, the characteristics of wood materials. The wood materials have been used throughout history. Until recently, wood materials have been used in their natural form, essentially unchanged from a tree in the forest except for drying and seasoning. Today, wood is still used in its natural form, but is also used as part of composite materials like plywood. Plywood is just thin layers of natural wood sandwiched with glue to make a stronger composite material. In this chapter, we will discuss wood used in manufacturing. Wood can be easily formed, shaped, and smoothed with many different types of manufacturing processes. Wood is used in furniture, cabinet making, home building, and many other commercial activities. Wood can also be used in heavy manufacturing and for design purposes, molds, jigs, fixtures, and other items that do not necessitate the expense of metals. Another thing is that some woods, like plywood, are stronger than steel by weight, so they have a better strength to weight ratio. That doesn't mean, you're gonna build skyscrapers out of plywood, but they do have their uses. So the classification of wood. Wood is classified as either a hardwood or a softwood, depending on the type of tree it comes from. The terms are a little misleading and have nothing to do with the actual mechanical properties of the wood. So hardwoods are not always stronger than softwoods and vice versa. Generally, hardwoods are stronger and harder than softwoods, but there are exceptions. So the famous one is balsa wood, which is very light and weak. It's a tropical rainforest hardwood tree, but it's weaker than southern pine or Douglas fir, materials that come from softwood trees. So deciduous trees, the broadleaf trees that typically shed their leaves in the fall, are hardwoods. So these include oak, walnut, birch, and ash. These species generally grow more slowly than softwood trees like pine. This makes them more expensive to harvest and buy, right? If the tree grows slower, there's not as much of it, so there's a supply shortage, which drives up demand. Conifers, trees with needles instead of leaves, remain green all year round, are softwoods. So some examples are pine, fir, hemlock, cypress, redwoods, and red cedars. Most lumber yards, at least in the Northeast, are filled with pine and Douglas fir as the primary materials for things like construction. The trees grow very quickly, they're easy to deal with, and they're cheap. So the composition of wood. Wood consists of hollow fibers. Unlike something like fiberglass, where the fibers are solid, wood has the benefit of having hollow fibers, which makes it lighter and doesn't lose as much strength. Okay? That the fibers generally run parallel with the tree's growth direction, so up and down. There are two main ingredients in wood. These are cellulose and lignin. About 70% of the volume of a tree is cellulose, about 25% lignin. Cellulose molecules are arranged in a nearly parallel orientation into units called crystallites. Crystallites are linked together into bundles called microfibrils. About 100 microfibrils join in the cell wall to form fibrils or lamella. The strength of the wood is influenced by the angle of the fibrils against the long direction of the cell. Essentially, the smaller the angle, the stronger the wood is. Adjacent layers of cells are bonded together by lignin. Lignin, like I said before, makes up about 25% of the volume, but it depends on the type of wood. Normally, hardwoods have less lignin and more cellulose. This makes them more dense and stronger. When a tree is viewed in section, aka cut in half, annular rings can be seen. Cells formed in spring have a thinner wall and are lighter in color. In fall, cells formed are thicker and darker in color. Each ring represents 1 year of growth. Now, this doesn't apply everywhere on the planet. Nearer to the equator, where seasons are not as pronounced, the growth rings will not be as pronounced. So if it's 90 degrees year-round, you don't really have that change in the cellular structure as a tree is growing. They're still technically there, but they're just more difficult to see. So this can make some tropical hardwoods prized for their grain or lack of grain, essentially just looking different from a tree that grows in the north. Softwoods and hardwoods have different cellular structures. So the cellular structure of hardwoods use cellular structures called vessels to move sap vertically through the tree. These vessels vary in size, but can be large enough to be visible without magnification. These appear as holes or pores. Hardwoods with large pores are classified as open-grained woods. So some examples are ash, mahogany, and oak. Hardwoods with small pores are classified as close-grained woods, so birch, cherry, and maple are some examples. The cellular structure of softwoods, sap is moved vertically through long tubular cells called tracheids. They contain a thin intercellular layer that binds cell units together. This glue can be easily dissolved with certain chemicals. This is how paper mills work. They have special chemicals that can dissolve the fibers of softwoods and easily make pulp, which is what is used to make paper. So the next topic are the effects of moisture. Fresh cut trees are known as greenwood. They contain about 20% moisture by weight. So what this means, if you cut down a tree, it weighs 100 pounds and you let it sit for a year and all that moisture dry out, the tree will weigh 80 pounds, right? It will also shrink. The wood will shrink naturally if it's left in open air, but there's a couple different ways to dry a tree. The majority of this shrinkage occurs tangentially. So a good way to imagine it, if you build a deck with green wood, you lay all the boards down, you got them long ways and short ways, you put them right next to each other, so all the boards are touching, you walk away for a couple weeks, you'll come back, there'll be a gap between the board widths, but the boards won't shrink that much long ways. So this was a major concern in ship and boat building. If you build a ship out of green wood and the boards shrink, there'll be giant gaps in the hull of your boat. If you build a boat out of dry wood and then you put it in the water, the wood is already fitted, it's going to expand and fill any gaps. For the most part, boats and ships are always built out of seasoned lumber, whether it's air dried or kiln dried. There was a episode in the War of 1812 in the Great Lakes where the Americans had no ships and they had to build some quickly. They felled trees and built small ships out of green wood. As far as I know, they didn't last very long, although they did accomplish their job. One tidbit is they didn't have any actual nails, so they had to use wooden nails, tree nails, to build the ship, so they weren't going to last that long anyway. So the moisture content of wood can be determined in several ways. So one way is boards can be physically weighed. So if you go to a lumber yard, you see a 2x6 that's pressure treated, aka it's going to be filled with whatever liquid keeps it from rotting. It's going to weigh more than a 2x6 that has been kiln dried. You can pick it up and easily tell the difference. One will weigh whatever 20% more than the other. This is kind of an inexact way of doing it. The next way is the resistance type moisture meter. This has two pins that are inserted into the wood, and the resistance between the pins is measured, kind of how you use a multimeter to measure resistance in a wire or an electrical system. The next is a dielectric or pinless moisture meter. This does the same thing, but just measuring the resistance on the surface. It doesn't insert anything into the wood. And then the last method is the oven dried method. So if you have a truckload of wood that came from one yard, you want to know the moisture content of all of it very accurately, you can take a specific piece of lumber, weigh it, put it in an oven until it's bone dry, take it out, weigh it. The difference will be the moisture content that's in that lumber. So lumber is dried in two different ways. So air drying is the way that's been used for centuries. It's just put out in open air, supported in some way so it doesn't bend or warp, and it just takes, months or years to dry out naturally. So the smaller the wood, the faster it's going to dry out, so the more surface area it has. So a 1x2 will season much quicker than a 4x6. So, 1 inch by 2 inch and 4 inches by 6 inches. The next method is kiln drying. Kiln drying, this is what most of the stuff at a lumber yard will have gone through. Basically a big oven that dries it in a matter of hours instead of weeks, months, years. Kiln drying also does another thing. It kills any bugs or fungus, mushrooms, whatever is living inside of that wood. So if you ship something in a container overseas that's made out of wood, it has to be kiln dried. So plywood is always kiln dried. So if you build a pallet out of plywood, you're good to ship it overseas, doesn't matter. But if you have dimensional lumber, like 2x4s, there has to be a stamp on there somewhere that says it was dried in a kiln, which means there's no bugs in the wood. The next topic is industrial stock, so basically what's out there. Most wood in a lumber yard is softwood, either pine or fir. Yard lumber comes in 3 classifications. So dimensional lumber is softwoods and hardwoods that are dimensionally accurate and have a good surface finish. These boards are made to be used immediately in furniture or trim, whatever you need. That's very expensive because, again, it's been sanded and is dimensionally accurate. These are available up to about 1 inch thick and about 12 inches wide. A typical lumber yard may have oak, pine, cedar, a couple of varieties of lumber. The next is factory and shop lumber. These are used for remanufacturing purposes in mills that produce fabricated items like doors, windows, cabinets, molding, and trim items. So these are typically the poorest grades of softwood because they're going to mill them anyway. They're going to put them in big machines, cut them down, and a lot of it is going to turn into sawdust anyway. The next is structural lumber. So these are the framing and deck materials that you may be familiar with. So things like 2x4s, 4x4s, 2x6s. One thing I'll mention is the term 2x4 is the nominal size of the lumber. So they're not really 2 inches by 4 inches. They're really 1.5 inches by 3.5 inches. The nominal just lets you know what it is, and there's a handbook somewhere that can give you the actual tolerances on what that lumber is supposed to be. Another category is rough sawn lumber. So this has a very rough surface finish. This is basically the first step from taking something, a tree, and making it into rectangular or square shapes. This has giant saw marks all over it. It's not dimensionally accurate. Some plants buy this because they're going to do their own planing, jointing, milling, and making it into shapes and sizes that they need, and they'll attain their own surface finish. So that's it for Chapter 11, Characteristics of Wood Materials.